All right, the next one is a graphing. Ooh, a lot of stuff going on here. So how do you graph y equals sine of 3 times x minus pi over 3 plus 2? So there's so many things going on here. Wow. All right, so as far as the teaching goes, I think there's a couple things we need to make sure we know how to do. First, I'll actually explain what I want my students to know, and then I'll go through what I used to teach. I don't teach graphing anymore, but I know some of you guys still do that. So the first thing is I expect everybody to be able to know what the sine of x graph just looks like. So at least what we call the initial period. So that graph is going to look something like that. Okay, so it goes down to -1, up to +1, completes a period in 2 pi, crosses at pi, has a maximum at pi halves, and a minimum at 3 pi halves. I don't know why. 3 pi halves. Okay, so it goes up to 1 and down to -1. So that's what we call the initial period. The next thing is you should understand what the transformations are. And so a times sine of, I like to write it like this, b times x minus c plus d. Okay, so we need to understand from here, we need to know what a, b, c, and d are, so therefore we can identify all the transformations. So the first, not so much the transformation, but the information of the graph. So the amplitude is basically the half distance from the max to the min of the graph. A nice way of saying it is like how high does the graph go to how low does it go with no vertical translation. So that's just going to be the absolute value of a. So in this case, that's going to be the absolute value of 2, which is equal to 2. The next one is identifying the period. So the period is going to be how long it takes the graph to repeat itself. So with no transformations, you can see that the graph takes 2 pi for it to repeat itself. But when you have a b, what you're going to do is take 2 pi and divide it by b, or the absolute value of b. Which in this case is 3. So I have 2 pi divided by 3, and that's just going to be my period. The next thing is we want to understand our our horizontal shift, which is going to be our shift inside of the parentheses, as well as our vertical shifts, which could be our shifts outside the parentheses. So in this case, I'm going to have a phase shift, which is going to be pi over 3 to the right. And I'm going to have a vertical translation, which is going to be up 2 units. All right, so basically, if I was going to take this graph, right, the amplitude is kind of the same thing as like a vertical stretch. You're going to stretch it. Instead of it going from -1 to 1, it's going to go from +2 to -2. The period, instead of being at 2 pi, is going to be at 2 pi divided by 3, so you can see that's being compressed. The graph is being shifted pi over 3 to the right, so for you guys, I guess it would be over that way. And then also the whole graph is being shifted up 2 units. So if you look at that graph and you think, wow, that's a lot of transformation, that seems pretty confusing, right? And it is. And that's why I don't really spend as much time going over it anymore, because, you know, we mostly are going to have calculators nowadays to be able to do something like this. So this is what I expect my students to be able to understand. However, I used to teach graphing, and when I used to teach graphing, you know, we used to do 2 periods. I'm not going to do 2 periods. I'm just going to take these transformations of the initial period, because I don't think it's just a good use of our time to do 2 periods nowadays. So to be able to graph it, there's 3 more pieces of information we need to understand. We need to understand the start, the end, and the x scale. Okay? So the start is where the graph starts. And what transformations, how are the transformations affecting that starting point? So you can see that the sine graph, the initial period starts at 0. So anything that's going to impact the graph is going to be what's inside of the function, basically our b times x minus c. So basically all we do is take bx minus c equal to 0. And then basically solve for x, and that's going to be the new starting point. So I'll just do 3 times x minus pi thirds equals 0. So you divide by 3 on both sides, add pi over 3, so you can say x equals pi over 3. So now the new starting point is going to be at pi over 3. The end, you can see the graph ends at 2 pi. So again, we're going to do the same thing. So it's bx minus c equals now 2 pi. So I'll do 3 times x minus pi over 3 equals 2 pi. Now in this case, I can't get away with that so easily, so I have x minus pi over 3 equals 2 pi over 3. Add a pi over 3, so x equals 3 pi over 3, which is equal to pi. So now you can see my graph starts at pi over 3 and ends at pi. Now the x-scale is how often that graph is going to, like where all these important points are. You can see these important points happen every, in this case, every pi halves, right? So you have either a max, an intercept, a min, and then a max, or an intercept. So to find the x-scale, all you're going to do is take the period, and this is only for sine, cosine, cosecant, and secant. Take the period and divide by 4. So our period was 2 pi divided by 3. If I divide that by 4, I think it's divided by 4. Yeah. Divided by 4, then that's going to be, that's the same thing as multiplying it by 1/4, which is going to be 2 pi over 12, which is equal to pi over 6. Okay, so here's what this graph is going to look like. So the graph is going to start at pi over 3. So this is not the x-axis, okay, or the y-axis. This is just going to be at pi over 3. And then basically I'm going to have 4 different points. So I'm going to have pi over 3. Here it's going to be 2 pi over 3. 3 pi over 3, which is just pi. 4 pi over 3. Uh-oh. Wait a minute. What happened here? What did I do wrong? That's not... Oh, pi over 6. I'm an idiot. So the x-scale is at pi over 6, right? So if you're going to add pi over 6, it might be helpful to understand this as pi over 6 is 2 pi over 6, right? 2 pi over 6 reduces down to pi over 3. So therefore, this would be 3 pi over 6, which is pi halves. Let's write that down below. So this is 3 pi. I guess I'm covering up myself. Sorry about that. So this is going to be 3 pi over 6. 4 pi over 6. 5 pi over 6, and 6 pi over 6. Okay, so you can see here, those are my points. This reduces actually to pi halves. This is going to be 2 pi over 3. That can remain 5 pi over 6, and then this can be reduced to pi. And then the other point, again, don't assume that this is the y-axis, because if you think about this graph, it has an amplitude of 2, so it goes down to -2 up to +2, and the graph is being shifted down or up 2 more units. So really, this is actually going to be at 0, and now the graph is going to go up to 4. So I'm kind of running out of space here. So I'll just say, so it's at 0, so that's going to be up at 2. So let's say put that at 2, and that's at 4. Okay. Let me get this out of the way. So anyways, goes to 2, graph starts here, max, intercept, minimum, and there. So there you go. That was a long explanation, but graphing is tough, and hopefully at least everything else I covered for you is going to help you out. But yeah, that's